டென்னிஸ் சூப்பரா இருக்கும். அதுதான் நிறைய ஹாலிவுட் எல்லாம் போவாங்க டென்னிஸ். ஹாலிவுட் கிரிக்கெட்
கணக்கு
the IoT. Today is not IoT. Tomorrow onwards we are starting with the next sessions. So because I'm having the schedule, so the given tomorrow onwards about IoT. So I shared the screen just now. Just please check whether it is visible or not. Then we will start the session on it. Just keep the message if you are getting the screen or not. So 28th November means tomorrow we will start with the IoT and along with IoT to all. And after that, as pixel. Coming to the next one, image, video, and kernel, kernel. If you understood these four things, then it's easy for you to train the data set what you're having of images or videos. So before going to that, I need to say a definition of the image. So before going to that, I just want to say the pixel definition. Pixel is nothing but combination of what is that least intensity value in the picture. In picture, if you're seeing the television, you can see the horizontal and vertical lines. In that horizontal and vertical lines, whatever you're seeing here, each and every box, you can call it as a pixel. So the pixel definition will be, so it's a combination, sorry, it's a least in intensity value of the picture. You can say it as pixel. Okay. So coming to the next one, the next definition will be image. Image is a combination of rows and columns or combination of pixels or collection of pixels, we can say. So here you can see if you want to identify the image, it's a combination of pixels. Okay, so what will be the combination of pixels? Rows and columns. So the size may be based on your picture size. That may be a 1 KB, 2 KB, 3 KB, 100 KB. That is your choice. But collection of the pixels, you can say it as an image. Okay, now you can see, I'm saying collection of the pixels. How this picture is formed. You can see, this is my picture. For that, I took here the pixel values. Can you see? Here I dragged and that pixel values you can see, so like that entire pixel values will be there. That's why the definition of the image we are saying combination of the pixels. Now you can see the kernel definition is nothing but combination of some pixels. Actually this is entire picture, but from the entire picture you dragged here only, means some kernel only you dragged. So combination of some pixels, you can call it as a kernel. Combination of whole pixels or collection of whole pixels, you can say it as an image. Then the definition of the video will be the same. Collection of images or frames, pictures, you can say it as a video. That's why if you're seeing the video also, you're taking the picture in our mobile continuously. If you're seeing the pictures, then you will think like that is a video. How you're thinking means, so the video will be constructed because of the collection of the frames or pictures. So that is the definition. And if you want to take any type of the images to load into the program, you should know the formats of the images. Why the formats or these many there? The one a formation of the image will be enough from file format. Why you're taking means based on the quality of the picture, based on the clear picture you're having jpg, jpeg, bmg, bmp, png, tif, like that. So jpg, jpeg are the basic informations, basic less quality is jpg. Compared with the jpg, jpeg is better quality, png is more better quality compared with the jpg and jpeg. So like that here so many extensions will be there based on the file formats. And you can see what will be the image types. So why you want to know the image types means, if you want to start to train the data set of the images, you should know the file formats along with the types of the images. Then only you can do the training of the data set of images. So now you can see the first one will be color image. Also we can call it as primary colors, because whatever you seeing the every images, so the images everything is comes under from the primary colors only. Because by using of RGB, red, green, blue only, we got these many colors, pink, gray, what is it, white color, everything is considered from the RGB only. By the combination of the RGB only, by the changing range of RGB only, we got those many colors. That's why the colored image, or you can say it as RGB type, or we can say it as a primary colors. So that is the primary color. And you can see if you're taking the primary color, I will tell you later in detail about the colored image. Coming to the next one as grayscale. The grayscale is nothing but it doesn't have any colors. It's have only intensity. If you're seeing this second picture, the first picture will be RGB picture. The second picture you can see we don't have any colors, but intensity will be there. That's why the picture is very clear. But coming to the third one, black and white image or binary level image, bi-level image, anything you can say. That you can say it as black and white image. You can see here, you don't have any intensity value. That's why it's showing the shape of the image, either black or white. If it is showing like that, then you can say that is black and white image. Okay, so these are the types of the images what we are using to do the conversions in the working of deep learning model. So the first one, I said the colored image. Colored image having the three colors RGB, red, green, blue. So if you are seeing any pixel, I said the pixel is nothing but the least intensity value here, right? In this, you can see each and every box should have three colors for colored image. That is only RGB. And each and every range of the RGB is 0 to 255. Why I want to say this 0 to 255 range means if you're seeing the colored image, the range will be 0 to 255. Red, green, blue. 3. Based on the color changing range, the colors are changing here. That's why you're saying it as primary colors too. Each color having 0 to 255 range and 24 bit size. You can see how it's converting. The colored image and just after that it just converted into this gray image. Okay. So this will be color to gray. And you can see if you are taking the gray picture, I said for the colored image, each and every box have three values. But coming to the gray image, how many values will be there? Only the single value. What is the single value? Intensity. The intensity is nothing but the light value. The light range will be 0 to 255 and it's having only the single channel. That's why 8 bits there. Then you can see here, this is a picture of pixel values. Then you can see in this how the values will be there. 94, 95 means each and every box having only the single value means the intensity value. If you're taking color picture, you can take the three values. I think you have seen the three values. Like these three values will be there. Okay, coming to the next one is black and white. You can see the black and white. If you're taking of any picture, it should have either 0 or 1 based on the threshold value. This you can call it as binary image. Okay, now you can see types of the another type of the images RGB and CMYK. These are the primary colors RGB. That's why you're calling it as a RGB is the primary color, and secondary colors will be there. That is cyan, magenta, yellow color. Why RGB is primary and why CMY or the secondary means you can see here. If you are combining red and blue, the magenta is coming. And if you are combining green and blue, you are getting cyan color. Combining of red and green, you are getting the yellow color. So like this, you are getting first colors, the combination of the RGB. That's why RGB is first primary and CMY or secondary colors. K is nothing but the black color. If you're combining both RGB, you can get white color. Red is 255, green is 255, and blue is 255. You will get white color. So if RGB or 000, then you can get the black color. That will be the combination of colors. So now you understood what will be the image, but you should know about the image processing if you want to go through with the digital image. So in image processing, you're having two options, analog and digital. Analog is nothing but the images should be in a white and black format. So what you're seeing, the scanning hard copies, printing flexes of black color, everything. You can see the hard copy. You're going to the Xerox shop and you're giving the one paper and you want to get the copy. You don't want to make any changes. Just simply how to give, you can get the copy and you can come back. That is about analog image processing. So you're giving input without making any changes. You're getting the output that you can call it as analog image processing. Now you can understand what will be the digital image processing. The digital image processing is nothing but whenever you're giving the input should be changed to get the output. That is only you are saying it as digital image processing. You can see if you're taking any of the picture to keep the status, sometimes you won't satisfied to keep the status directly or to the WhatsApp or Instagram, anything. Why means we're not satisfied. We need to make some changes. You need to increase the contrast, brightness, need to add the emojis, or you want to convert into binary format, color to gray image, like that, black and white image, or you want to add any emojis, you can add. So how, what you're doing with the image, if you're not satisfied, that is only you're saying it as a problem. When you're satisfied after adding everything, that is a solution. If you want to do like that, not only for the entertainment applications, for medical purpose or for any business sector, will be the same. So what are the steps to complete the digital image processing? The original digital image processing picture format will be the different, but here, what are you taking digital image processing? These are the main four steps. So many steps there. We just converted into single four steps, simple steps that are input problem, pre-process, techniques, and output solution. Why I'm saying here input is problem, output is solution, because for input you're applying some of pre-processing and image processing techniques, then you're getting the output, means you're making some changes in input. That's why I'm saying the input is problem and output will be the solution. Now you can see why you want to use after input the pre-process. Directly you can apply the image processing techniques. No, why you are using pre-process means whatever you're taking the input, that should be very clear. Then you can give to the techniques. Then it will give better accurate result. That's why we are using pre-process. Now you can see what will be the techniques will be there. So these are the techniques what you're seeing. So here you can see some of the techniques. So image acquisition, enhancement, filtering, segmentation, compression, retrieval. Like there's so many techniques will be there. So what will be the first technique? Image acquisition. So image acquisition is nothing but if you want to acquire any input image or video from the set of inputs, then you can say it as an image. Coming to the next one is, so this first step also you can call as like input problem. Image acquisition is nothing but input problem you can call. So coming to the next one is pre-processing. What is the meaning of the pre-processing? When you're applying image of the input to the technique of the image processing, so you have to do the resize, conversions, or applying the filtering process to the techniques. Why you want to use like that? Because whatever giving the input image, it won't be possible to get the better size. Maybe first image may be 256 by 256, second picture may be 300 by 400. So if all pictures are different sizes of the input, then you can't get better accurate result. Then you have to change all pictures into single size. That's why you are using the resize. And conversion, why you are using means if you have colored image, it's not possible to calculate the values in a simple way. It will take too much of time compared with the gray image. That's why sometimes you need to convert the colored image into gray or black and white. And sometimes you need to use a filtering process also. Having any noise, you have to remove the noise. That purpose, you need to use the filtering process. Okay. Now you can see this is the colored image. Okay, resize means you can increase or decrease the size like this. So resize is nothing but you can see the size, you can reduce the size. Okay, so gray conversion and black and white conversion aside, you can see the colored image, each and every pixel values like this. These values you should convert into single values. That is only you can say it as gray to, sorry, color to gray. So like that it will convert. If you want to get the black and white image, then you have to convert these single values into either 0 or 1. So these are the techniques. So now image acquisition will be completed. Another technique will be image enhancement. What is the meaning of the image enhancement? What you can do? You can see this picture. The picture of the first picture is not clear. Then the second picture is very clear. Why? You have applied the enhancement to increase the brightness or contrast. If you want to do any techniques regarding for the brightness, contrast, filtering, frequency techniques, then you can use in image enhancement technique. This is second technique in image processing. First technique will be image acquisition to get the any of input from the set of inputs. Then the third technique will be in image processing segmentation. So I'm saying all techniques we won't use at a time. Based on your requirement, based on your application, you need to use a techniques. So here the segmentation will be there. What will be the meaning of the segmentation? You can easily understand the segmentation is nothing but it should identify the edges of the each and every part, what will be there in a picture. Then you can say that is image segmentation. Okay, that will be color segmentation will be there, gray segmentation will be there, black and white will be there. Based on your requirement, you how to use. In segmentation, one of the technique is edge detection. In this edge detection, two type of techniques will be there. If you need entire all small edges also, you can use transformation technique, or you need to get the only main edges. You can see here you are getting only main edges, then you can use region based techniques, then it will give the sharpness where you are having the edges. Okay, so coming to the next one as image compression. So the segmentation you have seen, image compression. Image compression is nothing but two compressions will be there. Lossy compression and lossless compression. So why you are using the image compression? To reduce the space. For example, 1 GB it's taking means you can convert into 500 MB to save the space. But in that, permanent compressions will be there, or temporary compression will be there. That's why you're using lossy and lossless. Next one is recognition or feature extraction. After getting the edges, you need to say, for example, I'm taking my face and I have seen edges of eyes, nose, mouth, lips, and entire face. So I recognized edges like that on my face. Then you have to say which edge is related to the which feature. You have to identify the features. Then you need to use recognition step here. Okay, so like there's so many applications will be there for face recognition, number plate detection, lane purpose, car parking, driver monitoring, forensic applications, traffic sign applications, film industry based, any type of the applications we can use this image processing. And next, another some of security applications also there, security based technique also there. First one is cryptography, second one is steganography, third one will be the watermarking. These also image processing techniques, but we are using for the security purpose. The first technique will be what? Cryptography. Cryptography is nothing but the simple step. Cryptography is nothing but you want to give the key in a binary format to encrypt or decrypt the information, then you can use cryptography. Steganography is nothing but if you want to hide any text in your input. The input may be image, video, audio, text, anything of your input. In that input, you have to hide any image. Then you can use steganography part for it. Okay. So if you want to hide any image with your input, then that you can say it as watermarking. Watermarking is nothing but if you want to hide any image into the original image or video, anything in input of any information. If you want to hide image, then you can say watermarking. If you want to hide the text, then you can say steganography. If you want to do encrypt decrypt of the binary code, then you can say it as a cryptography. And after that, you're having image fusion. So image fusion is nothing but it will use for medical applications, business applications, and as well as multimedia applications. How it can use? So image fusion is nothing but it will combine two or more pictures into a single picture. That's you can call it as image fusion. So that will be based on a average fusion based, pixel based, color based. You can do. Okay, so like that, here also in security based, so many applications will be there. Fingerprint authentication, voice print based, facial features, iris recognition, hand geometry. Like there's so many applications will be there. So you can see, I'm taking off input image, I'm doing the pre-process, and you can see so many type of segmentations on it. So here, this is one of the segmentation technique. If you want to identify any tumor also, you can identify by using image processing techniques. And image enhancement, how it will be, you can see this is the original image. If you want to do the enhancement, you can see the noise will be there. You can remove the noise, then you can get the better picture. So like that, anything you can do. Restoration also you can do with the image processing. So this is original image, you just restored with the better cleared image. This is also one of the technique. Okay, so that will be the information. Now you can see uh, the practical part setup with image processing, how you are applying. And before showing to the practical part setup, so I will tell you the steps how you want to do the application with image processing. First, if you want to do any application, if you want to try the images of the data set, first you need to import the libraries. Like import or load dataset. After that, pre-process dataset. Next, visualization of dataset. Next, splitting of dataset. Next, create or create deep learning model. Next, fit database, train part database into deep learning model. Deep learning model. Then train data set. Now you input image, then do pre-process for the input image. This we have done yesterday. These last steps. Then compare input features with retrained model. With retrained model, then you'll get the results. So wait a minute. Just to see the steps, within 1 minute, I will start the practical session. But before that, we will see the small steps, how to read the image, how to display the image, everything I will say. And after that, finally, these based application I will say. So wait for 1 minute. I will open the coding part and I will show you. Good afternoon. No audio means I didn't stalk anything. Just I kept in a mute. Okay. So now I'll come back again. So here you can see if you want to start these concepts. So first I said the load data set, pre-process and visualization. So here you can see whatever you need the libraries that you have to load. And after that, the data set, entire data set you have to load. And after that, you have to do the pre-process. Means you want to do the resize, gray conversion, like that. You want to get ready the data set with a better format. And after that, visualization. Then after completion of the visualization nothing but we have to display the images, that's it. And splitting of the data, you need to split the 100% of the data into train and test part. Then what are you split in that train data set, you have to use the creation of deep learning model. And after completion, you can take that trained data to splitting of trained data to the deep learning model, then it will get trained. And after training, the information will be converted as pre-trained model. That is only we given yesterday, but we didn't see how it's getting trained everything. Now you can see. Okay. So before going to that, we can see before starting of these applications wise, we can see how to read the image, how to display the image, or how to read the video and how to display the video. And after that, we can proceed to the next one. So here I'm taking ideally. So you can use ideally for basic coding parts, and for the more coding parts, you can use Jupyter Notebook also. So I will show you the coding parts in ideally. So after that, you can see the next setup part. Okay. So now the first one will be I'm taking the file option. Now I want to see how to read the image, how to display the image, everything. Okay. So now you can see if you want to read any image at anywhere, the syntax will be the same. So first I want to read and display the image and display image. So how to do? The first one will be I'm taking INP variable, and in that I need to read the image. If you want to read the image, then you have to load some of the packages. That's why I'm calling first import CV2. And you know very well about import CV2. Why we are using import CV2. This package uses to work with the images, and import numpy as np. This you have to use. So np. What is the meaning of as? We are giving a shortcut name for it. Now I have to read the image and I want to display the image. That's why I'm taking one of the variable inp is equal to cv2 dot imread. In between the braces, I need to call any of the image. I'm just calling inp.jpg. I don't know where is the picture. So that's why I want to save the coding part and I'm saving into the music folder. Wait a minute, I will see any of pictures will be there. Okay, so in pictures, I'm saving with the name of main one. This is my, what is that, file name. So I want to take inp.jpg picture, and where I'm having, I should go to the location. So I'm just going, my code location will be in a pictures, and here having any image, I don't have. So then I want to get any of the image. So I'm trying to get any of the image to get the output. Okay, so I'm taking this image and I'm keeping here, and my image name I'm changing with INP, and my extension will be the JPG. So now I will go to my coding part. Okay, so here I can go, and my name is my image name is inp.jpg. So here I want to say one mandatory thing. If you are giving any input file, that may be image, video, audio, Excel sheet, anything, that should be with the variable name along with the extension name, and these entire information should be in a quotes. That is important thing. Okay. So now you can see, after that, I want to display the image. That's why I'm taking cv2.imshow of, and if you want to display the image, the displaying of image, uh, file name you have to call the title. Any of title you can give here. I'm giving input image is my title. And from where you want to display the image, from the INP variable, I took and I need to display the output. Okay. So wait a minute. Okay. So it should display the image like this. You can see, but I'm having my input image, it's displayed. Okay. So now how to read the image, how to display the image, you have seen. Now how to do pre-process with it. I said the pre-process will be there, right? The first one will be in a pre-process. What will be the first one? Resize. If I want to do the resize, how it will be? How it will be the resize. Now I will see how to do the resize of the image. So I'm taking here IMPR is equal to CV2 dot resize, and between the braces I need to take the size, how much size you need to change, but I want to change to my INP variable of INP, and with the size is 600 comma 700. So I don't know how many rows and columns. I'm giving 400 rows, 600 rows and 700 columns. Now if I want to display the image, cv2 dot my variable name as INPR for the resize. I want to take cv2.imshow. At anywhere for the imshow, to display the image, keyword is imshow. So I want to call here window name as resize image, and which one I need to call here? INPR. I have taken the INPR. Now I need to display resized output also. The first title will be input image. You can see what will be the title for it, input image. Now you can see what will be the size of the image. Sorry, what will be the title of the image? Resize image. So like that you can get resized image too. Now what I'm doing, after completion, uh, I need to get the output with, in pre-process, the second step will be what? Conversion. In pre-process, the second step will be conversion. So conversion means RGB to gray, gray to black and white, that you need to do. Then how to do the RGB to gray conversion? So for that I'm taking INP GINP is equal to CV2 dot CVT color, and between the braces. So I'm taking the variable name as INPR INPR comma. So you have to take CV2 dot color. So actually here the caps letters color underscore BGR to gray. This is a syntax. This will be to convert colored image into the gray. So from the OpenCV package, if you are using CVT color and for the resized image you need to apply, then the picture will be converted into BGR to gray. So don't you get confused here? So because actually in Python, it won't take RGB picture. It will take RGB to BGR actually. So BGR in Python, we can display the image in a BGR format. So if you want to convert that also, you can convert, no problem. I will show you that BGR to RGB conversion also. But in Python, it won't take as like a RGB. It will take the picture will be BGR. So now I am taking CV2 dot So actually the Python will be the case sensitive. You have to call very properly. So cv2.im show. I'm giving here gray image, gamma, where you are having the gray image in INP variable. So now I want to run the program. I need to get the picture with gray too. Okay. So gray picture also came. Now you can see if you want to see the what is it gray conversion. This is RGB to gray, right? RGB to gray. So now you want to see, actually it's not RGB to gray, we can say it as color to gray, because now you are doing BGR to gray. Okay, so how it's look like the BGR to gray? I am taking here our INPG is equal to CV2 dot CVT color in between the braces. I am taking INPR resize picture I am taking, but I want to do here CV2 dot color underscore BGR to RGB. Now I need to convert this picture. So again case sensitive, then you need to convert into small letters. CV2.im show. In this, you need to give the picture name as BGR to RGB image, comma, which variable I need to call? IMPG. Now you can see original colored image, actually how it's look like. Okay, so CV2 not defined. Yeah, sorry. So here I didn't call properly CV2. This is okay. So this is the BGR to RGB conversion. Okay. So now BGR to RGB conversion also completed. If you need, you can do the BGR to RGB, BGR to RGB. Otherwise, no need to do. Okay. So now resize is completed. RGB to gray conversion is completed. Now next one you have to use black and white. How to convert the black and white of the image. So I am taking here to do the BW conversion. So here I am taking INP. Before that underscore I am taking, because the threshold value want to check every time. INP BW is equal to CV2 dot threshold. So you need to take the threshold. Okay, and between the braces you need to take threshold of that GINP variable, comma, so 100 comma 255. This is the minimum and maximum value to find out the threshold value. So next CV2 dot thresh binary. Thresh binary. Okay. So this is a keyword. Thresh binary is used to convert the information from gray to black and white. So now I'm taking CV2 dot IM show in between the braces. So I'm taking BW image, okay, comma, here I need to call INPBW. Then it will convert into black and white. If you are adjusting zeros and ones, then you will get a black and white picture is in different way. So this is the gray picture. This is a BGR to RGB picture. This is a gray picture exactly. And this will be the colored image. Like that you can take the resize, everything. Okay. So these are the formats if you want to do the any type of conversions in a pre-process. Ma'am, type CV2 instead of CV. Yeah. So actually, only the thing when you're calling CV2, then you have to use entire programming with the CV2. If you're calling here CV, then you have to use the CV for entire programming part. Otherwise, it will show not defined, no module named, like that. So if it is showing no module named, then you won't get any type of what is it? You are getting no module named, then you have to install some of the packages. This will be the conversion. If you want to use these information, then you have to go with the same process, the coding part for the video also. You have to use the loop condition for it. That's it. That you can call it as video processing tool. So I will show you that one too. So for example, if you want to start with the video processing, so then you have to take here cap is equal to or INP is equal to CV2 dot video capture. You have to take video capture. So still what I showed, that is about input images. So if you want to take the video, this will be the format. Okay. So these I am taking indent the region. Why I'm taking the indent region, I will say. So here you can see CV2 dot video capture of 0. Actually, 0 is nothing but what are you having the input video that will be start with your live camera. Means input video capture 0. If you want to take any stored video, you can take INP dot MP4 something like that. MP4. If you are taking live video, then you have to use here 0. So I'm using live video. I don't want to go through the saved video. And here, after that, if you started with this, then you have to start with the while condition. Why you want to take the while? True is nothing but it's a continuous loop. The video is nothing but there you have to use. So here you have to see uh, ret comma frame is equal to, actually there we have used for the image reading purpose cv2 dot im made, but here you have to take inp dot read. That's it. Okay. So now the inp variable. Okay, here also will take inp. That will be the better. So inp and the INP now the video will be stored in INP variable, and after that if you want to do gray conversion, black and white, everything, and at the end of the time you have to use one thing. So INP dot release and as well as destroy all windows. I am taking here INP dot release because after closing the video it should close. That's why we have to use INP. That is only you're having the variable name. That's why. Next one, CV2 dot destroy all windows. In that, you need to take the small letters for it, and the caps letters also there. You have to use caps letters one. Okay. So now you can see the video should start here. Okay. So okay. So wait a minute. I will check the variable name. Then that will be the better for it. So it should come the video as like a continuous loop condition format like this. Okay. So actually my system getting slow. That's why it's showing like that. Otherwise it should open the camera and it should display the all output videos. Okay. Yeah. So size is not enough, I think so. Otherwise it will show. It's getting slow. That's it. Okay. Yeah. So same loop condition it will go and it will try to complete the loop condition for it. Okay. So this is the process how to read, how to display, how to work with the video. So this is only for the single, but I said for the application it will be the full data set training process. These steps you can see now. So still now you have seen only this one, but for single picture. Now you will see for more pictures. I'm just going to the Jupyter notebook and there I will show you how it will be. Okay. So here you can see this is the concept if you want to read the images for more. Okay. So here what I said, you need to import the packages exactly what you need, and after that you need to load the type of images what you're having. Actually, this application is about medicinal plant. What is it? Plant based tomato. What is it? Leaf recognition based disease there or not? Okay. The concept will be disease there or not. You have to check that will be only for entire images of what is it, a leaf based. Okay, so tomato based, and the tomato leaf will be detect having any disease or not. So tomato leaf based, whether it's having disease or not, you have to say, but that purpose you are taking some of the tomato types here, and for that you have taken the loop condition. Now what you are doing, so how I said, like a pre-process loading of the data set, and next one pre-process visualization. These three steps will be there in downside. So in these load defined data, in these you have loaded the data and you have done with the pre-process. How you're doing? See, train data and test data you're loading by using of TQDM, and you can see each and every image you are loading, you're reading, and you are converting into RGB, BGR to RGB, then you are doing the resize. If you did like that, the all pictures are storing into images variable, and labels, tomato leaf blight, black spot, something names will be stored in the labels. Like that, in load data defining function, you loaded the data and you completed the pre-process like this. And after loading and pre-processing, then you have to do the visualization. That purpose I took here define examples. In that I given the figure size as 5. So 5 pictures it should display randomly from the data with the X label, Y label. You can see this is the visualization of the 5 pictures. So like that, I loaded the data, pre-process, visualization. After that, you need to split the data. The splitting of the data also already completed, train and test here only. So then what you want to do, you have to create the CNN model. I'm creating the CNN model, convolution neural network, with the layers of convolution, pooling, flattened, and dense layer. So like that, you are creating a CNN model. After creation of the CNN model, what you want to do? You want to try fit the train and images with the labels. Then you will get the accuracy and loss. Now you have to create the pre-trained models. That is CNN H5 model and JSON model. Okay, so like that, you have to load the data set, you have to do the pre-process, visualization, then you want to create the CNN model. For it, you have to apply the train images with the labels, then it will get the accuracy and loss, and finally, it will convert the trained CNN model into pre-trained models of H5 and JSON. What will be there in a H5? H5 having weight features values of the picture, JSON having layers of the deep learning. These pre-trained models for the extension code of it, then you have to run the program now. So that will be how to load the data set, how to train the data set of the images. This will be the extension. If you want to see any front end part along with the back end, this is the coding. Now I'm running checking of the input. If I want to give the input, I should give the input, then it should check with the data set, then it should give the result. For it, this extension code we are using. Okay, what I shown in a Jupyter notebook, that is only training of the data set with the CNN model. Now in this .py file, the code will be there. If giving any input, then it should give the result. That you can see in a website page. So I'm waiting for it. Okay, so here you can see the website IP address came, copy the IP address single time, then go to Chrome at anywhere, then paste. Then now you can see this is about website. The website name will be tomato leaf disease detection using deep learning. Now you have to upload the input image. So I'm going to the pictures. Okay, code. I'm taking the test images. Any of the input image I need to collect and need to upload. Then you have to click on the upload. Then you can see it's showing tomato as early bright. Confidence is nothing but how much percentage it's recognized properly. 80.41 percentage. Just go to the back home and upload of any of other picture, then it should come the result. Okay. So this is the process how to train the data set of the images and how to display the image in a website. So till now have any doubt you can check. Otherwise we can close the session. Hope you understood. And in Jupyter Notebook, what I showed, that is about how to train the data set. And in ideally at the end of the time I executed, there you are just checking if you are giving input how it's recognizing with image processing. Okay, so this is the step, and till now having any doubt you can ask me. Hope you understood. And tomorrow, day after tomorrow will be IoT based. So having any doubts, please keep message. And entire completion of the all days, then we will share you these files to you. Okay, so till now have any doubt? Yeah, thank you. Thank you to all. Yeah. So not only thanks, having any doubt also you can keep the message, no problem. So actually yesterday one of the person is asked ma'am how to do the fine tuning process. So I will show you that fine tuning process. I think you can see the screen, right? So I'm having the small code. I will show you that how to what is that do the fine tuning. So I'm opening the Google Colab. Here I will open Google Colab. Okay. So if you want to wait, just please wait. One of the person yesterday asked. So how to do the fine tuning? Actually, that is a simple process only. So just I want to show that's it. I will show you the file of it, how it's look like. Okay, in this file you can see how it will be. So the fine tuning will be the same. You are having already the model, but for it you have to add the more data set. That's it. Okay. So here you can see you're having a bird model, and for that you need to add some of the information. Then it will get trained. So T5 model, BERT model, like there's so many models there. So here you can see. So you can see in this result, I'm having the input text and target text. Input text is nothing but my input result, and target text is nothing but I want to get the output if I'm asking these questions. So this is my data set. For that, I have already T5 pre-trained model. For it, I'm adding this data set by using of train and test. Then finally it will get trained. If you're asking any input question like this, then it try to give the answer. So whenever you're uploading new data set to the already pre-trained model, that you can call it as like fine tuning process. Okay, so this will be the concept. Still now having any doubts, you can ask me. And day 3 attendance link also shared in a group in chat box. Please check with that. Okay. Yeah. If you completed, then you can leave the meeting. Thank you.